All right, so in this video, we're going to start talking about some other parts of graphs. So we've already talked about, like x-intercepts and y-intercepts, domain, how far left and right it goes, and the range, how far up and down it goes, and the vertex, that kind of thing. So what we're going to look at now, and this is all going to be, using our graphing calculator for the most part. We're going to talk about turning points. Let's see, what else we're going to look at. Turning points, intervals of increase and decrease, and relative max and relative min. So they're pretty simple concepts, but sometimes kids will get them mixed up between the two. So I think there's a set of notes in a PDF. You can refer to that, but check out the video here. So a turning point, it's the x value for which a function goes from increasing to decreasing. Now increasing, for a function to be increasing, that just means that from left to right, so the x values, as the x values get bigger, so do the y values. It's kind of like, when you talk about lines, it's kind of like positive slope. So this quadratic here, it's got positive slope right here. But then after that, after it reaches 2, after 2, it starts going downhill. It's got negative slope. So from left to right, this function is increasing. Right? As x gets bigger, the y values also get bigger until it gets to 2. So once it reaches 2, it starts doing the opposite. Right? It starts going downhill. So that would be your turning point, is x equal 2. All right. Let's talk about interval of increase and decrease here. So an interval of increase, it's all the x values for which y is getting bigger, for which y is increasing. So we said earlier that from way over here until it gets to 2, so 2 is the spot where it switches. So for all the numbers before 2, so negative infinity right here, from negative infinity to 2, this function is getting bigger and bigger. Right? So this would be your interval of increase. The other way to say that, if this means all the numbers from negative infinity to 2, you could also say that in algebraic notation. It would be all the numbers that are less than 2. So what this means is that for all numbers before 2, so all these numbers way over here, negative 5, negative 6, as this function goes to the right, as the x values are getting bigger, the y values are increasing as well. So this function is increasing on negative infinity to 2. And then for the decreasing, it's the same idea. After 2, so after you get here, as the x values get bigger, as they go this way, your y values start to fall. Right? So from left to right, this graph is decreasing as x gets bigger and bigger. This thing's going to keep going down and down and down. Right? So you would say it's decreasing from 2 to infinity. Or you could say it's decreasing for all the numbers that are bigger than 2. Right. Moving on here. So for this picture here, we've got 2 turning points. All right, so negative 2, that's the x value for which it goes up to down. So that's a turning point. And then right here is another turning point, and it's the x value at that spot. So the turning point is actually 0. Right? The turning points are those x values where it changes direction. So for the interval of decrease, it is decreasing from negative 2 until it gets to 0. So in this little window is the only spot where where the graph has like negative slope. So it's going downhill from negative 2 until it gets to 0. I know it's tempting to say negative 2 to negative 4, but you always want to refer to the x values here when you're talking about the interval of increase or decrease. So you're really just referring to the turning points. Right? So from negative 2 to 0, this thing is falling. All right, and then it's increasing everywhere else. So from from zero, as it goes to the right, so from zero as it goes out to positive infinity, these y values are increasing. So that's that part right there, 0 to infinity. And then it also increases for all of these. So from negative infinity until it gets to right here. All right, that's where it stops increasing when it gets to negative 2. So that would be negative infinity all the way to negative 2. Or you could say all numbers that are less than negative 2. All right. While I'm here, notice how it's parentheses on all of these. Right? It's it's got doesn't have the bar there. All right. So these are all open dots, I guess. Or what that means is that it doesn't include it. So it's decreasing from negative 2 to 0, but it doesn't include negative 2 or 0. That's what the parentheses mean. The reason that is because when it gets to negative 2 or when it gets to 0, so like when it's on that one spot, it's not increasing or decreasing. Right? At the turning points itself, it's not increasing or decreasing. That's why they never include the endpoints. That's why it's never brackets there. Okay. All right, one more quick one here. Sorry, this video is taking a long time here. All right, your relative max or your relative min. All right, so turning points are the x values where it goes from increasing to decreasing or from decreasing to increasing. The relative max or the min, it's the y values at that turning point. So the y value at that spot would be 0, all right, because it's up and down 0. The turning point would be negative 2 though. And this is a relative maximum because it's it's kind of, I don't know, it's higher. It's got a high spot. It doesn't have a low spot like this one. Remember, like the quadratics, if they opened like that, we said they had a maximum. It's the same idea there. Let's see, where's that? And then for the relative min, same idea. It's the y value where it goes from decreasing to increasing. So it's the y value at the turning point, which in this case is negative 4. So you remember the turning point itself was 0 because that's the x value, but the y value at that spot is your relative minimum in this case. All right, that's enough for today.